Hi guys, let's look at the next question in the chapter Midpoint Theorem and its converse. Again, let me revise what is midpoint theorem. Midpoint theorem states that in case in a triangle you have a line which joins the midpoint of two of its sides. So in this case, let's take the two of its sides being in this way. So if this side and this side are equal and these two sides are equal, which means these are two midpoints, the line which joins the midpoints will be parallel to the third side and will be half of it. So if this is x, this would be x by 2. Perfect. So here we're looking at two midpoints and a line segment joining the two midpoints. It will make it to be parallel to the third side and it will be half of it. And the converse of it basically means, which is the opposite of it, which means in case you have a line which joins the midpoint of a side and this line is parallel to the third side. So here, if these two lines are parallel and one point which joins this is midpoint, then it means that this part and this part will be equal. So there are three variables. The variables are two midpoints and parallel. Two of them will be given. In this case, the two midpoints were given. The parallel is expected. In this case, one midpoint was given and one parallel was given, which means the other is a midpoint. So now let's look at the question which we have. And like I said earlier, enough number of times, most of these questions won't have a drawing, which means you will need to learn how to draw a rough diagram. So A and B are midpoints of parallelogram ABCD. So let's look at a parallelogram ABCD. Let's first draw the parallelogram ABCD and then we look at the midpoints. So A and B are midpoints of AB and DC. So A, B, C and D. L and M are midpoints. So this is L, midpoint of this, and this is M, midpoint of this. Why are they equal? Because since AB is equal to CD, therefore half of AB will be equal to half of CD. Perfect. AB and RDC are parallelogram. Prove that DL and BM. So let's join DL and BM trisect diagonal AC. Oh, so if this is my diagonal AC, and let's give them some names. So if this is point E and this is point F, what we need to prove is AE is equal to FE is equal to FC is equal to 1 by 3 of AC. Well, that's what we need to prove, that these are three equal parts and this is 1/3 of AC. Perfect. So let's start writing. What I know is, number one, AB is equal to CD. Number two, half AB is equal to half CD. Why is this? This is opposite sides of a parallelogram are equal. So then this is AB and CD will be equal. So what it means is AL is equal to BL and number 4 is DM is equal to CM. This is given. And this is, let's, 1 second, this is DM is equal to CM is equal to half of CD and AL is equal to BL, which is half of AB. This is given, right? So we'll combine them. So from from 2, 3 and 4, let's see what we get. From 2, 3 and 4, what we get is number 5, which is AL is equal to BL is equal to CM is equal to DM, which is equal to half of AB, which is also equal to half of CD. So all this information we know. That's why I've already marked them as equal. Next, LB is parallel to MD. Yes, LB is parallel to MD. Why? Since AB is parallel to CD. Therefore, LBMD is a parallelogram. Why? since 1, therefore this is not since, this is therefore. Therefore LBMD is a parallelogram since one pair of opposite sides is equal and parallel. So LBMD is a parallelogram, which means LB is parallel to DM and LB is equal to DM, which also means that DL is parallel to BM and DL is equal to BM. So now let's look at this triangle. Let's look at this triangle ABF. So in triangle ABF, like I said, as soon as you see a midpoint, you should try looking at triangle where one is midpoint and it is parallel. So let's write this down. Number 7 would be LD is parallel to BM, and number 8 would be LD is equal to BM, because this is a parallelogram. So let's start writing this down. Number 9 would be L is midpoint. Number 10 is LE is parallel to BF. So using converse midpoint theorem, what do I get? What I get is LE, not LE, is equal to half of FB, and what I also get is E is the midpoint of AF. E is midpoint of AF. So that's what I get. What it means is number 12 also means is AE is equal to FE. That's what I get. So AE and FE are equal because in this triangle ABF, this is midpoint, this line is parallel, which means E is also the midpoint of AF. So now that we've got one of these two equals, I have to prove now FE and CE are equal. Do they form up any triangle? Yes. Now let's look at this triangle DEC. Let's see if it will help us. Let's look at this triangle DEC. So let's start writing this down. In triangle DCE, number 14 would be M is midpoint of CD. Number 15 is MF is parallel to DE, because this is basically a parallelogram. BLDM is a parallelogram, which we already proved. So using converse of midpoint theorem, what do I get? I get number 16, which is MF is equal to half of DE, but we don't need this information. What I also get is F is midpoint of CE. What also it means is FC is equal to FE. Perfect. So now I know that AE is equal to FE and I know that FE is equal to FC. So let's combine from 13 and 18. I get AE is equal to FE is equal to FC. So this is what they wanted, that is trisects, but let's write this down. Therefore DL and BM trisect, which is 3 equal parts of AC. So this is what we get. AE, FE and CF are equal. Perfect. Let's look at the next question. The next question that we do will be question number 8. Let's look at the question. Question number 8 says ABCD is a quadrilateral in which AD is equal to BC. Already marked. EFGH are midpoints of AB, BD. Okay. We need to prove that EFGH is a rhombus. So how can we prove it to be a rhombus? If we prove that these 4 sides are equal. So what I need to basically prove is EF is equal to FG is equal to HG is equal to HE. All 4 sides are equal. If I can prove this, well, I will be able to prove that this is a rhombus. Now again, as soon as I see midpoints, I am basically looking at triangles where there are two midpoints being joined. So now let me first look at the triangle ADC. So in triangle ADC, are there any midpoint being joined? Yes, G is midpoint, H is also midpoint. So let's start writing. Number one, G and H are midpoints. Therefore, using midpoint theorem, what do I get? What I get is number 2, which is GH is equal to half of AD, which is the third side. So GS is equal to half of AD. Now let's look at the second triangle. The next triangle that I'll try and look at would be ABC. Now this would, why would I look at ABC? What are the midpoint being joined? E and H are being joined. Perfect. So let's look at this. In triangle ABC, number 3 would be E and H are midpoints. So what does it give us? Using midpoint theorem, let's see what we get. We get number 4, which would be EH would be equal to half of BC. So EH is half of BC. Perfect. So that was the second triangle we looked at. Let's look at the third triangle, which will be BCD. So let's look at triangle BCD. So in triangle BCD, what do I get? Number 5 would be, in this case, G and F are being joined. So G and F are midpoints. So using midpoint theorem, I get number 6, which is GF is equal to half of BC. Done. And that brings me to the last triangle which we can see here. The last triangle which we can see here would be, so we've taken ADC, we've taken ABC, we've taken BCD. Let's look at ABD. Let's look at triangle ABD, which is this triangle. So let's write this down. In triangle ABD, what do we get? Number 7 would be, in ABD, E is midpoint and F is midpoint. Yes, E and F are midpoint. So E and F are midpoints. So using midpoint theorem, what do I get? Number 8, I get ABD EF is equal to half of AD. So let's see what I can get. This is half of BC, this is half of BC. So from 4 and 6, what I get is number 9, which is EH is equal to FG is equal to half of BC. So I've got EH and FG equal. Next, from where is AD? This is AD. So from 2 and 8, which are both talking about AD. Let's see what I get. Number 10, which is GH is equal to EF, and both of them are equal to half of AD. So now I know that both pair of opposite sides are equal and parallel, but they are equal to AD and BC. But what is given is AD is equal to BC. This is given, which means half, therefore half of AD will be equal to half of BC. Right? So what I get is number 13. So from 10, what I get is GH is equal to EF is equal to half of AD, which is equal to half of BC. Since half of AD is equal to half of BC, this is from number 12. So what I get is this is my number 14, or rather this is 13. GH is equal to EF, and from 9 and 13 I get number 14, which is EH is equal to FG is equal to GH is equal to EF, which is equal to half of AD, which is also equal to half of BC. So now I have got all four sides equal. Since all four sides of EFGH are equal, therefore quadrilateral EFGH is a rhombus. That's what they wanted us to prove. We've proven that this is a rhombus. Perfect. Let's look at the next question. The next question that we do is question number 10. So let's look at the question. Question number 10 says DEF are midpoints of the side AB, BC and CA in triangle ABC. Something means something somewhere. Let's look at this diagram first. Let's look at this rough diagram. So this is, let's start marking. A, B, C is the diagonal triangle. D is midpoint of AB. So this is my point D. This and this are given equal. E is midpoint of BC. So E is midpoint of BC, and F is midpoint of AC. Perfect. Right? So AE meets DF at O. Okay, so AE, I didn't name this, this is F. AE meets DF at point O. So this is point O. Perfect. P and Q are midpoints of OB and OC. So we are joining OB and we are also joining OC. Perfect. So what is given is P is midpoint of OB. This is P, and what it's saying is B, and this is midpoint, and Q is midpoint of OC. This is Q, this is midpoint, this is point Q. Prove that DPQF, where is DPQF? This is D, this is P, this is Q, this is F, and so we need to prove that DPQF is a parallelogram. So what does it mean? It means that I need to prove that both pair of opposite sides are equal and parallel. So to prove that, DF parallel to PQ and DP parallel to FQ, and DF is equal to PQ and DP is equal to FQ. This is something that I need to prove. Whichever way we prove, even if I can prove one pair of opposite sides is equal and parallel, I will be able to prove this to be a parallelogram. So now let's look at certain triangles. So let's look at the big triangle first. So in the big triangle ABC, so we are looking at the big triangle ABC. Right? So this is the big triangle that I refer to. In this big triangle ABC, am I joining any midpoints? Yes, I am joining the two midpoints, which means DF will be half of BC and DF will be parallel to BC. Perfect. So I've got some part correct already. We moving in some direction. So let's look at triangle ABC. So in triangle ABC, number one would be D and F are midpoints. Done. So using mid point theorem, what I get is DF is parallel to BC, and number 3 would be DF is equal to half BC. Done. So we've looked at a big triangle. Now let's look at a one smaller triangle, which is BOC. Yes, let's look at triangle BOC. So in triangle BOC, what do I get? Is there any midpoint being joined? Yes, P is midpoint of BO, Q is midpoint of CO, so these two midpoints are being joined. So P and Q are midpoints. Therefore, using midpoint theorem, what I get is number 5, which is PQ is parallel to PC, and number 6, PQ is equal to half BC. So like the way we've been doing in previous questions, we've got one pair of opposite sides equal and parallel already done. Now let's look at the second pair of opposite sides. Let's see which triangles do DP form a part of. Yes, if I look at triangle AOB, then these is joining two midpoints. Perfect. So I've got visually what I wanted to look at. So in triangle AOB, let's look at this triangle. I get number 7, D and P are midpoints. So using midpoint theorem, what do I get? Number 8, which is DP is parallel to AO and DP is equal to half of AO. Yes, DP is parallel to AO and DP is parallel half of AO. Now let's look at the similar triangle on the other side, which is triangle AOC. So in triangle AOC, what do I get? Number 10, F and Q are midpoints. Using midpoint theorem, what I get is FQ is parallel to AO. Yes, FQ is parallel to AO, and number 12, FQ is equal to half of AO. Perfect. So I have proven that both pair of opposite sides are equal. So let's start writing this down. We've got our answer. So from where did we get parallel? So from 2 and 5, what I get is number 13, which is DF parallel to PQ. Perfect. 2 and 5, which is DF parallel to BC and BC parallel to PQ, which means DF is parallel to PQ. Perfect. And then from the next one, which is 3 and 6, what I get is number 14, which is DF is equal to PQ. So I've got one pair of opposite sides equal and parallel. That should finish my question, but we've already proven the other side also. So let's me write that as well. So we've got this and we've got this. So from number 8 and number 11, what I get is number 15, which is DP is parallel to FQ. And from number 9 and number 12, what I get is number 16, which is DP is equal to FQ. So we've got both pair of opposite sides are equal and parallel, since both pair of opposite sides are equal and parallel. Therefore, PQFB is a parallelogram. Perfect. That finishes this question for us. I'll see you in the next video. For now, bye bye, take care and be safe.